How one mad welder's rejected gun saved the 50 million manpower during WW2. March 1941, Mare Island Naval Shipyard, Vallejo, California. The welding torch flickered in the dim light of the submarine construction bay as Edward Nelson, an $11 a day welder, scrawled his frustration in a worn notebook. "There has to be a better way. This is madness." The Navy supervisors kept telling him to work faster, but they refused to listen to his solution. Through the maze of scaffolding beneath the wooden deck of a submarine under construction, he had just witnessed something that made his blood boil. A dozen workers spent an entire shift just to install a single section of deck planking. Enormous scaffolding structures filled the interior compartments below each wooden deck. Men with wrenches worked in cramped spaces, twisting nuts onto bolts that penetrated from above. Hours upon hours of labor just to secure wooden planks to steel frames. The traditional method demanded precision, patience, and precious time that America did not have as war clouds gathered over the Pacific. Yet here, in what would soon become one of the busiest shipyards in the world, attachment methods were the same as they had been for decades. Theodore Edward Nelson, 36 years old, California-born, had earned his mechanical knowledge the hard way: 15 years in machine shops across California, 15 years of learning how metal behaved, how electricity flowed, how problems could be solved if only someone would listen. What none of the Navy supervisors knew was that this frustrated welder had already solved their problem. And what Nelson did not yet know was that his simple solution, rejected and dismissed by his superiors, would soon save the United States Navy more than 50 million man-hours and fundamentally change naval construction forever. The transformation had begun weeks earlier in the cramped interior spaces below decks, where the real war against inefficiency was being fought every single day. The date was March 15, 1941, 8 months and 22 days before Pearl Harbor. Mare Island Naval Shipyard stretched across 635 acres along the Napa River in Vallejo, California, 25 miles northeast of San Francisco. Founded in 1854 by Commander David Glasgow Farragut, it was the first United States Navy base established on the Pacific Ocean. By early 1941, Mare Island had evolved into the premier West Coast submarine construction facility. The yard operated around the clock, 3 shifts of workers, 7 days a week. Submarine construction had accelerated dramatically as tensions mounted with Japan. The yard employed approximately 12,000 civilian workers in early 1941, a number that would eventually swell to nearly 50,000 by 1944. Among those 12,000 workers was Ted Nelson, employee number 3872. He earned $11 per day, working the day shift from 7 in the morning until 4 in the afternoon. His job was welding, primarily on submarine hulls and internal structures. He was good at his work, fast and precise, but increasingly frustrated by what he saw as wasteful inefficiency. The problem was everywhere he looked: wooden deck planking installation on submarines, destroyers, and aircraft carriers. The Navy specified wooden decks for several reasons. Wood provided better traction than steel in wet conditions. Wood was quieter for crew movement. Wood provided some insulation against the cold steel beneath. And in the event of fire, wooden decks could be more easily repaired or replaced than welded steel plates. But the installation method was archaic, labor-intensive, and painfully slow. The standard procedure, unchanged since the First World War, proceeded in a series of complicated steps. First, workers would drill holes through the wooden planks at precisely measured intervals. These holes would be countersunk to allow the heads of the attachment bolts to sit flush with the deck surface. Next, workers would position the planks on the steel deck framework. Then came the nightmare. Workers had to construct extensive scaffolding beneath the deck inside the submarine or ship compartments. Multiple levels of platforms were required to give workers access to the underside of the steel deck framework. Once the scaffolding was in place, workers above and below would coordinate to insert long threaded bolts down through the wooden planks and through corresponding holes in the steel framework. Workers below, standing on scaffolding platforms in cramped, dark spaces, would thread nuts onto the protruding bolt ends. They would tighten these nuts with wrenches, pulling the wooden planks firmly against the steel framework above. Finally, workers topside would fill the countersunk holes with wooden plugs, creating a smooth deck surface. The entire process was repeated for every section of decking. On a submarine, there might be several hundred square feet of wooden decking requiring thousands of individual attachment points. On an aircraft carrier, the wooden flight deck covered tens of thousands of square feet. The labor requirements were staggering. A typical submarine deck installation required a crew of 12 to 16 men working for 5 to 7 days. The scaffolding alone took 2 full days to construct and another day to dismantle. The actual bolt installation consumed the remaining time. Ted Nelson had performed this work dozens of times. He had spent countless hours standing on scaffolding platforms, threading nuts onto bolts in cramped submarine compartments barely 4 feet high. His back ached from the constant bending. His knuckles were scarred from slipped wrenches. His patience was exhausted. But more than personal discomfort drove his frustration. He could see the bigger picture. War was coming. Everyone at Mare Island knew it. The yard was already behind schedule on submarine construction. The Navy needed boats in the water, not sitting in dry dock waiting for deck installation. Every day of delay was a day closer to conflict. America was not ready to fight, and Nelson knew there was a better way. He had been thinking about the problem for months, turning it over in his mind during the long hours of routine welding work. The solution seemed obvious to him. Instead of bolting from above and threading nuts from below, why not weld attachment studs directly to the steel framework? Weld from one side only, from above. No scaffolding required, no nuts and bolts, no workers cramped in compartments below, just fast, strong, permanent welds. The concept was simple. A threaded stud, essentially a headless bolt, could be welded to the steel deck framework in a fraction of a second. The wooden planks would have threaded inserts or specialized nuts to attach to these studs. The entire operation could be performed from the topside only. No scaffolding, no below-deck work, no coordination between crews above and below. Nelson had seen stud welding before in a limited form. The technology existed for horizontal flat-plate welding. A small pile of flux powder would be placed on a flat steel surface. A stud would be positioned in the flux. An electrical arc would fuse the stud to the steel. But this method only worked on horizontal flat surfaces. The flux powder would simply fall off vertical or overhead surfaces, and naval construction required welding in all positions, vertical, horizontal, overhead, at all angles. This was the problem that had puzzled welding engineers for 20 years. How to make stud welding work on non-horizontal surfaces? Nelson thought he had the answer. It was so simple he almost laughed when the solution came to him. Instead of loose flux powder, encase the flux in a small ceramic cap. Attach the cap to the end of the stud. The flux stays in place regardless of position. He sketched his idea in his notebook: a handheld welding gun, a spring-loaded mechanism to press the stud against the steel surface, an electrical trigger to create the welding arc, a disposable ceramic flux cap on the end of each stud. The whole operation would take less than 1 second per stud. One worker could install dozens of studs in the time it currently took to install a single bolted connection. He took his idea to his supervisor, a Navy lieutenant named Morrison. The meeting lasted less than 5 minutes. Morrison barely looked at the sketches. "We have established procedures, Mr. Nelson. We follow Navy specifications. If you want to weld instead of supervising bolt installation, stick to your current assignments." Nelson tried again, approaching the shipyard's chief welding engineer, a civilian contractor named Hartwell. He explained the time savings, the labor reduction, the elimination of scaffolding costs. Hartwell was more polite than Morrison but equally dismissive. "Son, people a lot smarter than you and me have been trying to solve this problem for 2 decades. If it was that easy, someone would have done it already. Besides, the Navy has specifications. We cannot just change procedures because a welder has an idea. You need approval from Bureau of Ships in Washington. You need engineering studies. You need prototype testing. That takes years. We do not have years," Nelson protested. "We need submarines now. Hartwell shrugged. "That is not my problem, Mr. Nelson. My problem is building boats according to approved specifications. Your problem is doing the welding work you are paid to do." Nelson left the meeting angry and disillusioned. He had offered them a solution that could save thousands of hours per submarine. They had dismissed him without serious consideration, not because his idea was flawed, not because it would not work, but because he was just a welder. Because changing procedures required paperwork and approvals. Because innovation was less important than following established protocols. He made one more attempt, writing a formal letter to the shipyard commander, Captain Thomas Withers. The letter was carefully composed, explaining the current inefficiency, proposing the stud welding solution, estimating time and cost savings. He submitted the letter through proper channels, following the established procedure for worker suggestions. 3 weeks later, he received a reply, a form letter thanking him for his interest in improving shipyard efficiency, a polite explanation that all technical proposals were evaluated by the Bureau of Ships Engineering Review Board, a notation that his suggestion had been forwarded for consideration, a realistic assessment that the review process typically took 18 to 24 months. He would be notified if his proposal was approved for further study. 18 to 24 months. By then, the war might already be over, or lost. Nelson crumpled the letter and threw it in the waste bin. That evening, he made a decision that would change his life and alter the course of naval history. If the Navy would not listen, he would build it himself. He would prove his concept worked. Then they would have to pay attention. He cleared a space in the garage behind his small cottage in Vallejo. His wife, Emma, watched with concern as he began collecting scrap steel and welding equipment. "Ted, you are going to get yourself fired," she warned. "You are supposed to be working on Navy projects, not your own inventions." "This will help the Navy," he replied. "They just do not know it yet." Over the following weeks, working evenings and weekends, Nelson constructed his first prototype stud welding gun. The design was crude but functional: a pistol grip handle, a spring-loaded plunger to hold and press the stud, an electrical trigger connected to a welding power supply, a quick-release mechanism to load new studs. The most critical innovation was the flux cap. He experimented with different ceramic materials, different flux compositions, different cap designs. After dozens of tests, he developed a cap that held the flux securely, allowed proper arc initiation, and could be manufactured cheaply. By May 1941, he had a working prototype. He tested it on scrap steel in every position imaginable: horizontal, vertical, overhead, at angles. The gun worked flawlessly. A stud could be welded in less than 1 second. The weld strength exceeded that of traditional through bolts. And most importantly, it required no below-surface access. He brought the prototype to work and demonstrated it to several fellow welders during lunch break. They were impressed and excited. "This is going to save us so much time," one remarked. "You need to show this to Morrison," another suggested. Nelson shook his head. "I already showed Morrison. He was not interested." "Then quit and start your own company," a third welder advised. "Sell your gun to shipyards across the country. You will make a fortune." The idea had not occurred to Nelson. He was a welder, not a businessman. He had no capital, no manufacturing facility, no business experience. But the more he thought about it, the more sense it made. If the Navy would not use his invention, maybe private shipyards would. The Kaiser shipyards in Richmond were hiring. The Bethlehem Steel Shipyard in San Francisco was expanding. There were shipyards up and down the West Coast, all facing the same labor shortages and production pressures. On June 20, 1941, Ted Nelson submitted his resignation to Mare Island Naval Shipyard. His supervisor tried to talk him out of it. "Nelson, you are a good welder. Do not throw away a steady job for some crazy invention." But Nelson's mind was made up. "I am going to build welding guns," he told Morrison. "And when the Navy comes back asking to buy them, I hope you remember this conversation." He left Mare Island with $11 in his pocket, a garage full of tools, and a conviction that his invention would succeed. He incorporated the Nelson Specialty Welding Equipment Corporation on July 1, 1941. He borrowed $95,000 from the Reconstruction Finance Corporation, a government lending agency established during the Depression to support small businesses. With that capital, he rented a small workshop in Vallejo and began manufacturing stud welding guns. The first months were difficult. He had no customers, no reputation, no distribution network. He made sales calls to local machine shops and small fabrication companies, demonstrating his gun, explaining the time savings. Most were skeptical. A few were interested enough to try a demonstration unit. Slowly, very slowly, orders began to come in. By September 1941, he had sold 18 welding guns and several thousand flux-capped studs. Then, on December 7, 1941, everything changed. Pearl Harbor. The Japanese attack destroyed or damaged 8 battleships, 3 cruisers, 3 destroyers, and 188 aircraft. 2,403 Americans died. The United States was at war. Suddenly, shipbuilding was not just important, it was a matter of national survival. Within days of Pearl Harbor, the shipbuilding industry exploded into frantic activity. The Kaiser shipyards began building Liberty ships at an unprecedented pace. Mare Island Naval Shipyard received emergency orders for submarine construction. Bethlehem Steel and other private yards started working triple shifts. And every single one of these facilities faced the same problem: how to build ships fast enough. The traditional methods were too slow, too labor-intensive, too wasteful of precious time. Ted Nelson's phone began ringing. Shipyard purchasing agents who had dismissed his invention weeks earlier now wanted to place large orders. The Kaiser shipyards ordered 50 welding guns and 10,000 studs. Bethlehem Steel ordered 40 guns. Even Mare Island Naval Shipyard, where he had been rebuffed just months earlier, placed an order for 60 guns and 20,000 studs. Morrison, his former supervisor, handled the purchase requisition. There was no apology, no acknowledgement that Nelson had been right, just a curt official order and a request for prompt delivery. By January 1942, less than 1 month after Pearl Harbor, Nelson's small workshop could not keep up with demand. He was receiving orders faster than he could manufacture products. He needed a real factory, more workers, better equipment. He leased a larger facility in San Leandro, a few miles south of Oakland. The building sat in the middle of a cornfield, isolated and unimpressive, but it had space, power, and room for expansion. By March 1942, he employed 20 workers. By June, 50. By September, 150. The factory operated around the clock, 7 days a week. Welding guns rolled off the assembly line at a rate of 30 per day. Stud production reached thousands per day. Every major shipyard on the West Coast was now using Nelson stud welding equipment, and the reports coming back were extraordinary. A submarine deck installation that previously required 12 workers in 6 days could now be completed by 3 workers in 1 day. The elimination of scaffolding saved 2 additional days and freed workers for other tasks. The welds were stronger than traditional bolted connections. The wooden deck planks could be removed and replaced more easily for maintenance or repair. At Mare Island Naval Shipyard, submarine construction accelerated dramatically. The yard completed 17 submarines between 1941 and 1945, with an average construction time that steadily decreased as new techniques were implemented. Stud welding was not the only innovation, but it was a critical piece of the efficiency puzzle. By mid-1942, stud welding was being used not just for deck attachment, but for dozens of other applications: pipe hangers, cable supports, equipment mounts, bulkhead attachments. Any situation where a fastener needed to be attached to steel structure, stud welding provided a faster solution. The Navy Bureau of Ships, which had initially ignored Nelson's proposal, now studied his process intensively. Engineering teams analyzed weld strength, durability, and failure modes. The results confirmed what Nelson had known all along. His welds were not just faster than traditional methods, they were actually superior in strength and reliability. On November 19, 1942, just 11 months after leaving his $11 a day welding job, Ted Nelson received a formal visit from a delegation of Navy officers. They came to his San Leandro plant unannounced, a group of 5 men in dress uniforms. Captain Harrison, representing the Bureau of Ships, did the talking. "Mr. Nelson, we are here to inform you that the Navy has completed evaluation of your stud welding process. We have determined that your invention has saved the United States Navy an estimated 5 million man-hours in submarine and surface ship construction over the past 10 months. That number is expected to increase substantially as more shipyards adopt your technology." He paused, then continued. "On behalf of the Secretary of the Navy and the United States government, I am authorized to present you with a citation for exceptional contribution to the war effort." Nelson was stunned. They had rejected his idea. They had ignored his proposals. They had forced him to quit his job and risk everything to prove his concept. And now they were giving him a citation. Captain Harrison must have seen the conflict on Nelson's face. "I understand you submitted a proposal to Mare Island in early 1941, Mr. Nelson. I have reviewed that file. Your proposal was not properly evaluated at the time. That was a mistake, and I apologize on behalf of the Navy. However, your decision to develop the technology independently has resulted in faster deployment than would have been possible through the normal procurement process. Sometimes the best way to serve your country is to ignore official channels and just solve the problem." Nelson accepted the citation with mixed emotions, pride in his achievement, vindication for his perseverance, but also frustration at the bureaucracy that had nearly prevented this innovation from happening. The war continued. Production demands increased. Nelson's company expanded again, opening a second manufacturing facility in Camden, New Jersey, in March 1943. This East Coast plant supplied shipyards in New York, Philadelphia, Norfolk, and Charleston. By mid-1943, Nelson Specialty Welding Equipment Corporation employed over 400 workers and generated annual revenue of approximately $4 million. Ted Nelson still spent 16 hours a day in the factory, still dressed in shop workers' tan pants and shirts, still drew a modest salary of $1,000 per month. All profits were reinvested in expansion, equipment, and loan repayment. But his impact on the war effort was incalculable. The Navy's estimate of 5 million man-hours saved by late 1942 was just the beginning. As the war progressed and stud welding became standard practice across all naval construction, the time savings multiplied exponentially. By 1943, stud welding was being used not just on submarines, but on aircraft carriers, battleships, cruisers, destroyers, and hundreds of smaller vessels. The Essex-class aircraft carriers built by Newport News Shipbuilding and other yards used Nelson stud welding extensively for flight deck attachment and interior fittings. Each carrier required approximately 20,000 studs. The Navy built 24 Essex-class carriers during the war. The Iowa-class battleships used stud welding for deck planking, equipment mounts, and armor attachment. The Baltimore-class heavy cruisers incorporated the technology throughout. Destroyer escorts, landing ships, patrol boats, every type of naval vessel benefited from faster, stronger attachment methods. But the most dramatic impact was in submarine construction. Mare Island Naval Shipyard, where Nelson had worked and where his idea had been rejected, became one of the most efficient submarine builders in the world. The yard built 17 submarines during the war with steadily improving construction times. Portsmouth Naval Shipyard in New Hampshire became the champion submarine builder, completing 79 submarines between July 1940 and July 1945. Portsmouth's success was built on multiple innovations, but stud welding was a critical enabling technology. The yard adopted Nelson's system extensively, using it not just for decking, but throughout the boat's interior. The result was visible in construction statistics. Portsmouth launched 3 submarines simultaneously on January 27, 1944, the Redfish, Ronquil, and Razorback. A 4th submarine, Scabbardfish, launched the same day. 4 submarines in one day. No shipyard before or since has matched that achievement. At the peak of production, Portsmouth completed 32 submarines in 1944. This was approximately one submarine every 11 days. The Vallejo-class submarines, which made up the bulk of wartime production, averaged 12 months from keel laying to commissioning at Portsmouth. This was several months faster than other yards building the same class. Electric Boat Company in Groton, Connecticut, built 74 submarines during the war. Manitowoc Shipbuilding in Wisconsin, despite being on the Great Lakes hundreds of miles from the ocean, built 28 submarines that were floated down the Mississippi River to the Gulf of Mexico. Across all yards, the United States built 203 submarines during World War II. Each submarine required thousands of stud-welded attachments. Each stud saved minutes of labor time. Multiply those minutes by thousands of studs per submarine, by hundreds of submarines, and the time savings reached staggering proportions. But submarines were only part of the story. The real volume was in surface ships and merchant vessels. The Liberty Ship program, managed by the Maritime Commission and built primarily at Kaiser shipyards, produced 2,710 cargo ships during the war. Each Liberty ship required approximately 5,000 to 8,000 stud-welded attachments for deck planking, cargo handling equipment, defensive gun mounts, and ship fittings. The Victory ships, a faster and more advanced design, were built to similar standards. The scale of production was unprecedented in human history. At the peak of Liberty ship construction in 1943, American shipyards launched 3 new ships every day, 75 ships per month, 900 ships per year. This was possible only through radical innovations in construction methods, prefabrication, modular assembly, specialized workers, dedicated tools, and faster attachment methods. Stud welding was one piece of a larger revolution in shipbuilding efficiency, but it was a critical piece. The elimination of scaffolding freed workers for other tasks. The speed of installation reduced assembly time. The strength and reliability of the welds ensured that these hastily built ships could survive North Atlantic storms and enemy attacks. By the spring of 1943, the United States Navy had taken formal notice of Nelson's contribution. On May 11, 1943, the Secretary of the Navy presented the Nelson Specialty Welding Equipment Corporation with the Army-Navy E Award for Excellence in Production. The E Award was created in July 1942 to recognize companies whose production facilities achieved outstanding performance in manufacturing war equipment. Excellence in quality and quantity were the determining factors. Only about 5% of companies engaged in war work received this honor. The award consisted of a pennant for the factory and individual pins for all employees. The ceremony was held at the San Leandro plant with full military honors. Navy officers, Army representatives, and local officials attended. The factory workers, Nelson's employees, who had worked grueling hours to meet production demands, received their pins with pride. Ted Nelson, standing before his workers in his usual shop clothes, accepted the pennant and gave a brief speech. "We did not do this for awards or recognition. We did this because our country needed it. Every stud we make, every gun we build, helps bring our sailors and soldiers home safely. That is all the reward we need." But the Navy was not finished recognizing Nelson's achievement. Plants that maintained outstanding performance for 6 months after receiving the initial E Award were granted a star to add to their pennant. The Nelson Company earned its first star in November 1943. The second star came in May 1944. By the end of the war, the Nelson Specialty Welding Equipment Corporation had earned 2 E Awards with stars, one of only a handful of companies to achieve this distinction. The citations specifically noted the estimated 50 million man-hours saved in naval construction. 50 million man-hours. Let that number sink in. 50 million hours is approximately 5,700 years. If one person worked 8 hours a day, every day, it would take over 19,000 years to accumulate 50 million hours. This time savings came from one simple innovation, a spring-loaded welding gun and a ceramic flux cap. The time savings translated directly into ships in the water faster. More submarines hunting Japanese convoys. More destroyers escorting convoys. More aircraft carriers launching strikes. more landing ships delivering Marines to hostile beaches. Every ship delivered faster meant more combat power, more supplies delivered, more lives saved. The strategic impact was incalculable. But Nelson's invention had another unexpected benefit. The stud welding process required less skill than traditional bolt installation or conventional welding. With minimal training, new workers could perform stud welding operations safely and effectively. This was crucial as the war progressed and labor shortages intensified. Women entered the shipyards in unprecedented numbers. The famous Rosie the Riveter symbolized female shipyard workers, but there were also Wendy the welders. Women operated stud welding guns, installed deck planking, mounted equipment. Many became highly skilled at the process. Mare Island Naval Shipyard at its peak employed almost 50,000 workers, including 9,000 women. Kaiser shipyards employed hundreds of thousands, with women making up nearly 30% of the workforce. These women needed tools and processes that could be learned quickly and performed safely. Stud welding fit that requirement perfectly. By 1944, the tide of war had turned decisively in favor of the Allies. American industrial production overwhelmed Axis capabilities. The United States built more ships, planes, tanks, and guns than Germany and Japan combined. The arsenal of democracy, as President Roosevelt called it, operated at full capacity. Ted Nelson's stud welding guns were a small part of this massive industrial achievement. But small parts matter. In war, efficiency is measured in lives saved and battles won. Faster ship construction meant more naval power deployed sooner. More naval power meant more Japanese shipping sunk, more islands taken, more pressure on the enemy. The submarine campaign in the Pacific demonstrated this clearly. American submarines sank over 1,000 Japanese merchant ships, totaling approximately 5 million tons. They also sank one aircraft carrier, 8 battleships, and numerous cruisers and destroyers. This success was possible only because America built submarines faster than Japan could sink them. Japan began the war with a larger submarine fleet than the United States. But Japan built only 126 submarines during the war. America built 203. Every month of accelerated construction mattered. Every week a submarine reached the fleet sooner meant another week hunting enemy shipping. The Essex-class aircraft carrier program showed similar patterns. The United States Navy had 7 aircraft carriers in December 1941. By August 1945, the Navy had 99 aircraft carriers of all types. The Essex-class fleet carriers formed the backbone of this force. 24 were completed, each carrying up to 90 aircraft. The fast carrier task forces built around Essex-class carriers dominated the Pacific from mid-1943 onward. These ships shelled Japanese positions, launched airstrikes, provided air cover for amphibious landings, and engaged Japanese naval forces in decisive battles. The Battle of the Philippine Sea in June 1944 saw American carrier aircraft destroy over 600 Japanese planes in what pilots called the Great Marianas Turkey Shoot. This victory was possible only because America had more carriers in the right place at the right time. Faster construction enabled faster deployment. The D-Day invasion of Normandy on June 6, 1944, required 7,000 ships and landing craft. This armada, the largest amphibious assault in history, was possible only because American and British shipyards built landing craft by the thousands. The landing ships were crewed vessels, flat-bottomed boats designed to run up on beaches and discharge cargo. But they required rapid construction and reliable fittings. Stud welding proved ideal for landing craft construction. Cargo ramps, davit mounts, deck fittings, all could be installed quickly and securely. Nelson's technology, invented for submarine deck attachment, found applications throughout the landing craft fleet. After VE Day in May 1945, attention shifted fully to the Pacific. The planned invasion of Japan, Operation Downfall, was scheduled for November 1945. The operation would require more ships, more landing craft, more logistics support than any previous campaign. Shipyards prepared for another surge in production. Then, on August 6 and 9, 1945, Atomic bombs destroyed Hiroshima and Nagasaki. Japan surrendered on August 15, 1945. World War II ended. The massive military production machine began winding down. Contracts were cancelled. Workers were laid off. Shipyards closed or converted to peacetime production. The Nelson Specialty Welding Equipment Corporation faced an uncertain future. Military orders dried up almost overnight. The company, which had employed over 400 workers at its peak, now faced potential collapse. But Ted Nelson had prepared for this moment. During the war years, he had been thinking about peacetime applications for stud welding. The technology was not limited to shipbuilding. Any industry that fabricated steel structures could benefit from faster attachment methods: construction, bridges, buildings, tanks, pressure vessels, automotive. The possibilities were extensive. Nelson pivoted to civilian markets. He marketed his stud welding systems to construction companies, steel fabricators, and industrial manufacturers. The post-war construction boom provided new opportunities. America was building highways, bridges, skyscrapers, and suburbs. All required steel fabrication and attachment. By 1948, Nelson's company had successfully transitioned to peacetime production. The business was smaller than during wartime, but stable and growing. The company continued to innovate, developing new stud designs, improved welding guns, and specialized applications. In 1950, Nelson sold his company to TRW, a large industrial conglomerate. The sale made Nelson financially secure and allowed him to retire from active management, but the Nelson name remained on the product. TRW continued to market Nelson's stud welding equipment, maintaining the brand recognition Nelson had built. Over subsequent decades, the company changed hands several times. TRW sold to Phenatech Incorporated in 2000. Doncasters Group Limited acquired Phenatech in 2007. Stanley Black & Decker purchased the industrial division in 2018. Through all these changes, the Nelson brand survived. Today, Stanley Engineered Fastening manufactures and markets Nelson stud welding products globally. The technology pioneered by Ted Nelson in his garage in Vallejo remains in use worldwide. Modern stud welding is more sophisticated than Nelson's original design. Inverter power supplies provide precise arc control. Automated systems handle high-volume production. Robotic welders apply studs in automotive assembly plants. But the fundamental principle remains the same: a stud, a flux cap, a spring-loaded gun, and an electrical arc. 1 second per stud. No scaffolding required. The applications have expanded far beyond shipbuilding. Construction workers use stud welding to attach metal decking to steel beams in skyscrapers. Bridge builders use it for guardrail posts and lighting mounts. Nuclear power plants use it for cable trays and equipment supports. Automotive manufacturers use it throughout vehicle bodies for grounding points and trim attachment. The technology Nelson invented to solve a naval construction problem has found applications in virtually every industry that works with steel. But the most touching legacy of Nelson's invention is found in the restoration of historic ships. The battleship Texas, one of only 7 remaining ships to have served in both World Wars, is currently undergoing restoration at a dry dock facility. The ship requires extensive work to repair corroded hull plates and deteriorated fittings. The restoration team discovered that modern Nelson stud welding equipment is ideal for this work. They can attach new steel plates using the same technology Ted Nelson invented 80 years ago. Similarly, the submarine USS Pampanito, a World War II boat now preserved in San Francisco, uses Nelson stud welding for ongoing maintenance. The boat sits at the Embarcadero, hosting over 100,000 visitors annually. Keeping the old boat safe and functional requires constant attention. Nelson equipment allows the volunteer restoration crew to perform welding work efficiently without requiring certified welders for every task. Ted Nelson lived to see his invention's impact extend far beyond what he imagined that day in 1941 when he sketched his idea in a notebook. He saw stud welding become standard practice in shipbuilding. He saw it adopted by industries worldwide. He saw his name become synonymous with a welding process. He died in 1994 at the age of 89, having lived long enough to witness the end of the Cold War and the transformation of the world his generation had fought to preserve. The statistics of his achievement tell only part of the story: 50 million man-hours saved, 2 Army-Navy awards, thousands of ships built faster, billions of studs manufactured. But numbers cannot capture the full impact. Behind those statistics were sailors who returned home because their submarine was completed in time to join the fleet. Marines who survived because landing craft were available for their assault. Families who were not torn apart because the war ended sooner. The true measure of innovation is not just efficiency gained, but lives preserved. Ted Nelson, the $11 a day welder who was told his idea was impractical, saved more lives than many combat heroes. He did it not with weapons but with welding, not through destruction but through construction. The rejection he faced was not unique. History is filled with innovators dismissed by established authorities. Wilbur and Orville Wright were told powered flight was impossible by experts. Henry Ford was laughed at for suggesting automobiles could be mass-produced. Chester Carlson spent years trying to sell his xerography process before finding a buyer. What made Nelson different was his refusal to accept rejection. He did not argue with bureaucrats. He did not waste time trying to convince skeptics. He simply quit his job, risked his savings, and proved his concept worked. Then the market did the convincing for him. This is the essence of American innovation. Not waiting for permission. Not following established procedures. Not accepting that things must be done the way they have always been done. Just identifying a problem, developing a solution, and having the courage to implement it regardless of institutional resistance. Mare Island Naval Shipyard, where Nelson worked and where his idea was rejected, closed in 1996 after 142 years of service. Over its lifetime, the yard built 512 ships and repaired thousands more. The yard was responsible for construction of 44 submarines, including the last nuclear submarine built in California, USS Drum, launched in 1970. The base was declared a California Historical Landmark in 1960, and parts were designated a National Historic Landmark District in 1975. Today, the former shipyard is being redeveloped as a commercial and residential area. Some of the historic buildings remain, including the chapel, dry docks, and industrial structures. Walking through these preserved spaces, visitors can imagine the frantic activity of the war years when tens of thousands of workers built submarines around the clock. In Building 46, the old pipe shop that operated until 1984, there is now a small museum. Among the exhibits are tools, photographs, and artifacts from the shipyard's history. There is no specific exhibit about Ted Nelson. No monument to the welder who saved 50 million man-hours. His story is largely forgotten except among welding professionals and maritime historians. This anonymity would probably not have bothered Nelson. He was not seeking fame or recognition. He was solving a problem. He was making things work better. He was doing his part to help his country win a war. The fact that his solution worked, that it saved time and lives, that it changed an industry, those were reward enough. But there is a lesson here for every generation. Innovation often comes from unexpected places. Not from credentialed experts, but from working people who see problems every day and know how to fix them. Not from corporate research labs, but from garage workshops where tinkerers experiment until they find solutions. Not from official channels, but from individuals willing to risk everything on an idea they know is right. The next great innovation might come from a welder in a shipyard, a mechanic in a garage, a nurse in a hospital, a teacher in a classroom. It might come from someone official channels dismiss as unqualified, someone bureaucrats tell to follow procedures, someone experts assure is wasting time on an impossible problem. History suggests we should listen to these people. Not because all their ideas will work, but because the occasional idea that does work can change everything. Ted Nelson's ceramic flux cap was just a small piece of ceramic. His welding gun was just a simple spring-loaded tool. But combined, they eliminated scaffolding, saved time, increased safety, improved quality, and accelerated ship production at a critical moment in history. 50 million man-hours, 5,700 years. That is what one welder's rejected idea ultimately saved. And that number represents only the direct construction time savings. It does not account for the strategic impact of faster ship deployment. It does not measure the lives saved because submarines reached the Pacific sooner. It does not calculate the morale boost from seeing production goals exceeded. It does not quantify the deterrent effect of American naval power growing faster than enemies anticipated. The full impact of Ted Nelson's invention may never be fully calculated, but we can say with certainty that America's victory in World War II depended on industrial capacity as much as military valor. The battles were won by soldiers, sailors, and Marines. But the war was won by workers, engineers, and innovators. People like Ted Nelson who saw a problem and fixed it. Who refused to accept inefficiency when efficiency was possible. Who understood that in total war, every minute saved in production translated to lives saved in combat. As we face the challenges of the 21st century, this lesson remains relevant. The problems we confront, climate change, resource scarcity, infrastructure decay, require innovation at every level. Solutions will come not just from elite universities and corporate laboratories, but from working people who see problems clearly and develop practical fixes. The next Ted Nelson might be designing a better solar panel in a garage workshop. The next breakthrough might come from a factory worker who knows exactly what is wasting time and energy. The next revolution in efficiency might originate with someone official channels have already dismissed as unqualified. We need to listen. We need to encourage innovation from all sources. We need to reduce the barriers between problem identification and solution implementation. We need to remember that some of the most important innovations in history came from people working outside the system because the system refused to listen. Ted Nelson started as an $11 a day welder. He ended as a millionaire industrialist whose technology saved his country. But he never forgot his roots. He never put on airs. He never claimed to be anything more than a mechanic who saw a problem and fixed it. In his later years, when asked about his success, he would shrug and say, "I just made a better mousetrap. The world beat a path to my door." It was not genius. It was just common sense. But common sense applied at the right moment with courage and persistence can change history. That is Ted Nelson's legacy. Not the 50 million hours saved. Not the 2E awards. Not the global company that still bears his name. His legacy is the proof that one person with a good idea and the determination to implement it can make a difference. That legacy lives on every time a welder pulls the trigger on a stud welding gun. Every time a ship is built faster than the old methods allowed. Every time someone looks at an inefficient process and asks, "There has to be a better way." Ted Nelson asked that question in 1941. His answer helped win a war. What questions are you asking today? And more importantly, when the experts tell you it cannot be done, when the bureaucrats tell you to follow procedures, when the skeptics dismiss your idea, will you have the courage to prove them wrong? The history of innovation suggests that sometimes the most important thing you can do is ignore the experts. Trust your own observations and build the solution you know will work. Ted Nelson did exactly that. 80 years later, welders around the world still use his invention every single day. And somewhere, perhaps in a garage or workshop, the next Ted Nelson is sketching an idea that everyone says will not work. But they will be wrong because the best innovations do not come from following procedures. They come from people who see a problem, know how to fix it, and refuse to take no for an